Hello everyone, let's start the lesson 3 in chapter 1, algebraic expression, factorizing part. So in factorizing what we are going to do is we are going to separate the factors of an algebraic expression. First look at example. I'm got with what we did in the previous lesson, expanding brackets. So I'm going to write the term x times 2x plus 3. So we simply learned how to expand these brackets. We multiply each term inside with the value outside. So x into 2x, that is equal to 2x to the power 2. X into 3, that is going to be 3x. Now the reverse operation of the expanding bracket is called the factorizing. So if we do this in the reverse operation, that falls under factorizing. So I will try to do the same thing in the reverse order. So what we have in this right hand side, we have 2x to the power 2 plus 3x. To factorize, I have to look at what are the common terms for both of these terms in the left side. We can, if this 2 is not common because here we have 2 as the coefficient and 3 in the second term, so no numerical terms are matching. But when we look at the algebraic terms, we have x here, also x here, and there are 2 x's in the first term, and in the second term we have only 1 x. That means we can take 1 x out as the common factor and write the remaining parts in the bracket. We'll write extra step to make this a little bit more clear. I will write this 2x to the power 2 as 2 times x times again x, and here also the second term 3 times x. Now you can clearly see only a x term is common, so I'm going to take this common term out as x here and then write the remaining 2 terms inside the bracket. Here also only remaining part is 3. So the reverse process of expanding brackets is factorizing. Let's look at another example. Two x times y minus 5. If we expand the bracket, we go to 2xy minus 10x. Now if I rewrite the second term and try to factorize it, let's try to factorize it. We have 2xy minus 10x. We already know the answer, but let's try to do it the way that we did in the previous example. So for the first 2 terms, I can think this as 2 times x times y. This minus 10, straight away we can think the factors. We have to think for the factors of 10 in this case. The factors of 10, 10 can be 1 times 10 or 2 times 5. Since I have a 2 in the first term, I'm going to write this is 2 times 5 times x. Now we can see what are the common values. 2x and here 2 and x in the second term. So I can take 2x out from both the terms and I remain with y in the first term and 5 in the second term, but I have to be careful with this sign to minus 5. So this is how we do the factorizing. Let's try to do few example questions with this factorizing. Part A, 3x plus 9. For the 2 terms, I can think this as 3 times x. 9, I'm going to think because the numerical term in the first term is 3, so I can write 9 also, 3 times 3. So for the both terms 3 is common. I take 3 out, so I remain with x plus 3 inside the bracket. So easiest way is once you get the answer, let's try to expand the bracket and see if you can return to the original expression. Then what you have done is correct. But if you expand the bracket and come up with a wrong answer, a different answer, that means what you have done is wrong. It is always very easy to double check factorizing whether you have done the proper thing or not. Okay, part B. X to the power 2 minus 5x. Again, for the both terms, I can see x is the common term. For the first few questions, I will always try to write these in the expanded notations once more. So x and x common for both. I'm taking one x out. So I am remaining with x minus 5. Part C. 8x to the power 2 plus 20x. So I can see x is common, but also 8 and 20, they both have common factors. I can see 8 can be written as in many ways, but I'm thinking what are the common terms for both 8 and 20. I know 2 is common for both, also 4 is common. Since 4 is the higher factor, I'm going to take 4. So 4 times 2 times x. You don't need to write this if you already know how to do this. So, but just to clarify, 20 I can write 4 times 5 times x. Now we have common values 4 in both. Again, x term in both. So I'm going to take out 4x, and inside the bracket I have here 2 and x, so 2x, and here I have just 5. Okay, part D. Nine x to the power 2 y plus 15xy to the power 2. Again, I can see there are a lot of common terms. 9 and 15 both can be written as products of 3. So I'm going to write 9 as 3 times 3, x to the power 2 as x into x, and y. 15 I can think as 5 times 3, x times y to the power 2, y into y. So what are the common terms? I can see 3 is common in both. Again, I can see x is common in both, and 1y is common in both. So I can take out 3xy as a common factor out. What remains now is 3 and x in the first term, so 3x inside the bracket, and in the second we have 5 and y, so 5y. So this is the answer for the part D. Finally, part E, I have 3x to the power 2 minus 9xy. So again, I can write this as 3x times x minus 3 times, so let me rewrite it again. I can write 3x to the power 2 as 3 times x, 9 as 3 times x times y. So we have common 3x in both of the terms. So I can take 3x out as the common factor, and we are remaining with x minus 3y inside the bracket. If you expand the bracket, you should be always getting the original expression we tried to factorize. Now let's see how to factorize quadratic expressions. So first see what is a quadratic expression. Quadratic expression is a expression that has the form ax to the power 2 plus bx plus c. Most important part here is this coefficient of x to the power 2 term, this a cannot be equal to 0, and all a, b and c values should be a real number. So what are the real numbers? It can be usually real numbers are any positive numbers, any negative numbers, or any fractional values you see, or any surds that you know of. Mostly what are not real numbers are the square roots of negative or roots of the negative numbers, but for this scope you might not have gone through. You can assume any number that you know so far can be these ABC. What you have to identify in this type of equations are mostly there will be x to the power 2 term. There should be x to the power 2 term, and there is a x term, and there is a term that is without x. So let's look at an example how to factorize these. To factorize, I'm going to write a quadratic expression x to the power 2 minus 5x plus 6. So how to factorize these are, you have to multiply first coefficient a, the coefficient of the x to the power 2, and the coefficient of in the last term, that is c. So a and c, you first multiply a times c. So what is a and c in this term, in the example I wrote? So a is the value in front of x to the power 2. In this one it is 1. There is nothing, then nothing means there should be 1. And c straight away is this. So a is 1. Always try to identify what is a and c. So 1 into 6. So a is 1. And also in this instance let's write what is b also. B is minus 5. So always be careful to identify what is a, b and c. So a is 1, c is 6. So 8 times 6 is 6. And then what you have to do is after writing 6 you should be able to build b by the factors of this multiplication of c, a and c. So how to build b from this? B is minus 5. B is minus 5. So how to create b from this 6? So what you have to do is we have to think for the factors of 6. 6 can be written as 1 times 6 or 2 times 3. But none of these add up to minus 5. So how can we build minus 5? It should be always addition or subtraction. Can we get it from plus 1 and minus 6? Yes, but the problem is when we multiply that should be plus 6, but plus 1 into minus 6 is not plus 6, so we cannot take that option. Always now since this is a positive value, this should be either plus, both of the factors should be plus, or both of the factors should be minus. What if we add minus 1 and minus 6? That end up minus 7, not minus 5. Here plus 1 plus 3, it is plus 5, but minus 2 minus 3, if you use these two factors, these add up to minus 5. Okay, now we can break this middle term. What we are basically doing is we are trying to break the middle term into two terms. So to break it, now I can write this as x squared. Let me write a different color. To break it, I can write here as x to the power 2, and this minus 5x, I have understood the factors. How I can break it is minus 2x minus 3x. If we add these two, it's going to be straight away become minus 5x, and I have plus 6 here. Now for the first two terms, what are the common terms? Is x, so I can take x out and we have x minus 2. For the last two terms, I can take minus 3 out, and then inside the bracket I have x, and here I can write when you divide 6 by 3 you get 2, but when you expand the bracket it should be plus 6, so I have to put a minus sign here. Now you can see in both cases we have x minus 2, x minus 2. So I can take x minus 2 as a common factor out, and then x and minus 3 are the two factors. Let's recap the theory. So quadratic expression is an expression that is in the form of ax squared plus bx plus c, where a, b and c are real numbers and a cannot be equal to 0. And how to factorize these terms are always multiply a times a and c, and from the answer you get by multiplying a and c, you have to look for the factors and build b. Then you can break the middle term b into two values, that is allowing us to factorize this whole expression. The best way to master this and learn this concept is doing more and more exercises. If you do 20-30 questions on this factorizing, this will become your second nature. So let's do some more examples.